Okay, so today we're going to be talking about scatter plots and how we can use them to make predictions. So we're going to start off talking about trend lines. Now, we mentioned trend lines the very first day that we talked about this, and these are some examples of trend lines. Okay, so whenever a scatter plot demonstrates a linear, so that's a keyword right there, a linear relationship, a straight line, go ahead and write that, straight line, can be used to show the general pattern of the data. The general pattern of the data is the trend line. So a trend line or a line of best fit is a straight line, just like we talked about. So it's another straight line that should lie as close as possible to the points of the data. Now, to draw a straight line through some points, it's pretty obvious, pretty easy. So we're gonna take a look at some examples on what would be a good line of best fit and what would not be a good line of best fit. It's fairly obvious. So for example, number one, would this be a good line of best fit, or would this be a good trend line? No, because it's going in the different or opposite direction of the actual dots, right? A good trend line would go straight through here. So this would be, no, that'd be a bad example. Okay, what about number two? Well, number two goes straight through the points, and you want to try to get an equal amount of points above and below the line, and they did a pretty good job on this one. So yeah, I would say that would be a good trend line. Now this one's a little bit trickier. This is a good trend line as far as direction, but look, all the dots are on one side. There aren't any dots on this side. So this one, unfortunately, even though it's going in the same direction, wouldn't necessarily be a good trend line because you don't have it trying to get an equal amount above and below the line. Okay, same thing with number four. It's going in the right direction, but all the dots are on one side of the line. So no, that wouldn't work either. So the only one that actually works is number two, this one that goes straight through the dots. So let's see if we can use this information and make some predictions on it, because that's basically what trend lines are for. So if I were to describe this line right here, it says describe the association of the data. So we talked about this like on day one. It's moving in this direction. So I would say that that's positive. So I'm gonna put down that it's positive. And it's going in one general direction. It's not going up and down, like all wiggly, wonky. So this would probably be a good example of a linear relationship. So because it's linear, I can now draw a line of best fit. So you don't have to have a straight edge. You could just go ahead and freehand it. I'm gonna try to freehand it as best I can. Draw a line straight in between there. Okay, because this is sketch a trend line on the graph. Done that. So Milo wants to predict the value of y when x is equal to 10. How might the trend line you drew be helpful? Well, it kind of gives an idea. So at 10, so x equals 10 right here, the dots stop here, but if I kept going, I could make that general line kind of continue forward. So I could estimate or predict that at 10, where x equals 10, my y would equal around 45. So y would approximately equal 45. And that's how we use trend lines. So we draw a line and we're gonna make a prediction based off of it. So let's go ahead and take a look at these examples. So we're gonna try to draw a line in between these and make a prediction. It says, predict the value of y when x is 7. Okay, so x is 7 is right here. So I'm gonna draw a line. I'm gonna try to do my very best to freehand it. So right there. Okay, it's a pretty good line. So I'm gonna go ahead and at 7, it looks like it's gonna be about 40, approximately 40. So my y value would about equal 40. Now, if you notice, I'm not using the actual equal signs. This is an approximate symbol. This is about, or similar to, or close to, okay? So go ahead and try it and draw a trend line through number 7. Pause the video here and see if you can kind of estimate and guess where you think, predict the value of x, so you're predicting this, whenever y is 10. Okay, hopefully that was a good enough pause. Let's go ahead and draw the line. I'm gonna make my line, again, I'm gonna make it freehand right through there. Okay, it's pretty good. So predict the value of x when y is 10. So y is gonna be 10 here. X is gonna be approximately 10, just about. So I'm gonna say that x will be approximately 10. All right, fair enough. let's go ahead and try number 8. What do you think 8 is going to be about? So go ahead and draw a trend line through there. Pause the video and see what you get. Okay, so I'm gonna draw my line of best fit. Hopefully that was a good enough pause for you. So I'm gonna draw a straight line through there. Okay, pretty good. Now it says predict the value of of y when x equals 30. So I'm looking for y. It's gonna be about, I'm looking at 30. When x equals 30 right here, it's gonna be around, ooh, it's really, really close to 100, about 100. So I'm gonna say approximately 100 to 90. Could be 100, could be 90, but that gives us a very good prediction on what it's gonna be, right? All right, let's go ahead and move on. Let's see a real world scenario. What happens or how can this be used in the real world? So we have a scatter plot and it shows the age of several young polar bears and their weight in pounds. So we're gonna use the graph to answer these questions. So predict the age of a polar bear that weighs 50 pounds. So I'm gonna have to draw a trend line to get that prediction. So I'm gonna go straight through here. Okay, now if it weighs 50 pounds, that's gonna be the y. So y is gonna be 50, and what of my x? So it's about 50 pounds. So it's gonna be about 5 months. It almost hits exactly right at that 5 months. So I can go ahead and put down that it'll be approximately, or I'm gonna put about 5 months. And because that's gonna be my x, I'm gonna put x is gonna be about 5 months. Okay, so try and pause the video, see if you guys can predict the weight of a 10-month-old polar bear. So the weight is gonna be the y, so your y is gonna be approximately a certain amount of months, or a certain amount of pounds. So go ahead and pause the video and see what you get. All right, hopefully that's a good enough pause. Let's see. I'm going to predict that if I'm looking at 10 months is gonna be right here, just about, almost barely 100 pounds. So about at 10 months, the polar bear is gonna be around 100 pounds, approximately 100 pounds. It's a big polar bear. All right, let's try to do the last one together. It says a polar bear weighs 42 pounds and Jamie estimates that the bear is between 4 to 5 months. Is this estimation reasonable? Why or why not? So we're checking his answer. So pause the video and tell me if you think this is a reasonable estimation or not. Okay, so hopefully you've already decided your answer if this is good or not. Let's see. I'm guessing 42 pounds. So 42 pounds would be right here, right around here. And it's right between 4 and 5. So that's almost nearly perfectly where we need to be. So yes, this would be a good, reasonable estimation because it fits right at that trend line. Perfect. Now for number 10, another real world observation. So I know it's gonna ask me to do a trend line. I'm gonna go ahead and put one in straight away so we can save some time. There's my line. Now let's go ahead and take a look at what questions it's asking. It says, if Gregory has 45% of his popcorn remaining, predict the percentage of the movie he has watched. So I'm looking at the popcorn. Now the popcorn is gonna be the y. The movie watched is gonna be x. So if I'm at 45% of his popcorn, so 45% of his popcorn is right around here, that means that he has about 40%, like almost right at 40% of the movie watched. So I can go ahead and put down that x is gonna be about 40%. Okay, so try B. Brianna has watched 60% of the movie. Predict the percentage of her popcorn remaining. So popcorn is gonna be y, so my y is gonna be approximately a certain amount, and we know it's gonna be a percent. So here's my blank. So go ahead and pause the video, trying to figure out what you think it's gonna be. All right, let's see what you got. Hopefully that was a good enough pause for you to figure that part out. 60% of the movie brings me right around here, and that's gonna give me, that gives me around 10%. I hope that was about what you got. I got about 10%. It's pretty good. All right, so last one, Erica has watched 20% of the movie, and her brother bets that only 30% of her popcorn is remaining. Is his prediction reasonable? Just like the polar bear, is it reasonable that he thinks that? So let's go ahead and check. We have 20% of the movie, 20% is gonna be here, and it tells me I have about 80% of the popcorn, maybe 75% of the popcorn. So unfortunately, no, this is not a good prediction. Sorry about that. All right, Let's try the last one, quick and easy, for number 11. It says, the graph below shows the cost of several homes in Ashton's hometown based on the number of years since 1995. So Ashton sketched the linear trend line shown and predicts that if he purchases a home in 2002, it would likely have cost him about $375,000. That was in 2002. So we have to do some extra math on this one. So let's find out. 1995 to 2002 would be a couple of years, right? That'd be around 7 years. So I'm going to go 7 years out, because that's since 1995. He says it's going to be 375. Let's find out. Going to the trend line. Oh, look, 350 is right here. So 375, it's really, really close. So, I mean, it's pretty reasonable. So if I know that I have 7 years out, it's about 3, so I'd go ahead and put down, yeah. It would be reasonable for him to assume that it would likely have cost him about $375,000. Because it's right there at 7 years. So that's pretty much it for the examples that we have. Hope this made sense. If it does not, as always, come see me in tutoring.